I guess we'll get going. All right. Hey, everybody. Everybody knows this guy, which is great. So we'll be talking about one bug, two bug, red bug, blue bug, and yes, it's a riff on Dr. Seuss. I don't think I told you this story. So I was like, oh, I should get bug images. This will be awesome. And so I tried using AI. If you want to see something terrifying, type in Dr. Seuss style bug into any AI and see what it spits out. Don't recommend it. All right, so our agenda today, we'll go through our introductions of who we are, but you already know him, so it doesn't matter. The problem statement, the solution, example, and kind of a reusable framework for anybody else who thinks this is cool and wants to do it. All right, so hey, everybody, I'm Lee. I'm the American in the room. There's probably some other Americans in the room, hopefully. I'm not alone. Oh, hey. See, I do know somebody. So I'm a principal security engineer at Microsoft, and I do a lot of speaking primarily in the U.S., and I help run B-Side Seattle and help run Forward CloudSec. Forward CloudSec this year is in Berlin. If you're interested, the CFP just opened. I'm just going to do a plug. Hope nobody minds that. I'll let Patrick go.
Hi, everyone. I'm Patrick. I've been living in Ireland my whole life, and my whole security career has also been in Ireland. So I see some familiar faces in the crowd here, which is great. So I went from Symantec. So hi, folks. And then I went to Ward Solutions, and I did some consultancy work. Then I went to Icon. So hey, folks. And then Amazon, and now I'm with Microsoft, and I'm running the identity security team in Dublin. So that's been my journey. And Lee is my colleague in this effort, and this talk today is about one of the aspects of the approach that we've learned over the years. So,
all right. So here's our problem statement. So for those in the room, have you ever found a bug or a vulnerability or a threat or an issue or whatever you want to call it, misconfiguration? I can keep going. Or two, and wondering where the others might be hiding because they like to hide. All right, so we developed a program that we call variant analysis. So we're trying to solve for that problem. It's not enough for us to find a singular bug. We need to find out across our infrastructure, across our products. And obviously, we work in a complex environment with a lot of different tooling, a lot of different systems, and so that's not an easy thing for us to do. And we sat around chatting about what was working for us and what wasn't. And we're just doing this wrong. We're doing AppSec wrong, is what we decided. So a lot of times, if you are an AppSec person, you've done threat modeling, you've probably done perhaps code reviews, you've done maybe fuzzing, there's all kinds of stuff you've done, right? And you can see there's a problem. It's staring you in the face, but you don't actually know exactly what's wrong. So the classic example we use is a security boundary violation. So that's going to really come down to your environment. It's not something you can easily just be oh, I can totally see that this thing's talking to this thing, because it's usually going through intermediary steps. So you can't see from point A to point B to say, oh, there's a problem. So the other problem we were facing was, how do we gather and share evidence that we'd actually fixed everything, right? Because you could say, oh, yeah, we fixed everything. We're golden. But you need evidence to show that to your leadership to say, hey, we solved all the things. We never, let's be clear, we're never going to solve all the things. But for that specific thing, we solved all the things. So, you may have heard this quote from John Lampert, who's a Microsoft CVP. Defenders think in lists, attackers think in graphs. So we thought, oh, that's brilliant. What if we just flip it? Why can't defenders think in graphs? So we decided to use what we call breach path analysis, which you may also know as attack graphs. And we use breach path analysis to go and hunt for bugs. So the interesting thing about breach path analysis is it will tell you all the possibilities, right? It's not going to tell you the exact path any certain attacker will take, but it's going to show you everything. And so you have to actually have sort of you got to be creative and you've got to be patient because it's going to show you so much that it's going to feel like you're boiling the ocean, right? So a lot of it's about also trying to understand what you're trying to look for. So you have to be careful with breach path analysis because it's wildly powerful, but it's going to show you a lot of stuff. So this is why we say you need a map. This is our example of a map. And I'm going to turn it over to Patrick to explain how we use it.
Cool. So what Lee was talking about there is the classic problem that we've all experienced, I think, if you've worked in any security program for long enough. You end up with like all of these wonderful tools that give you all of these lists of things, and then they're all this list of problems that you have to deal with. And like, how do you prioritize them? How do you know what's important? Like, if you have a list of 3,000 things, how do you know like what's the number one thing that you need to fix right away? So like, burning it all down is great, but like, that's going to take time. And while that time is going on, then you don't know if somebody's in your environment, if they're looking at things or messing with things that they shouldn't be. So the attack graph helps us visualize what's going on here and like give us a context into this data and a way to analyze it. So like, you need your inventory, you need like a topological map of it, and then you need to start thinking with the attacker mindset. And that's the mindset switch that we took to kind of stop ourselves from trying to boil the ocean. So like, identity is a part of Microsoft, but it is huge. It could be an entire business on its own. So like, how do we make the resources that we have fit? Like, the scale of the environment doesn't fit into the number of resources. So we had to change something up. So we have like highly scaled simulated or adversary simulation in Microsoft, like with the red team or whatever. And I'm sure most of you are familiar with that term, and you might even have red teams in your own organizations. But they were already using attack paths to figure out like how they could win. So we collaborated with them and we figured out how can we, because it's just a tool, like how can we use this tool to help us know how we can win and work together. So this simulated environment here, you know, I'm sure most of your environments are a lot more complicated than this, but what this shows is that like, you have various different components to your service and your ecosystem. Like, you might have like a web component, like where people interact with it and they talk to your function app. So like, if you look at this environment and the function app in the middle, so if there's say for example, there's a remote code execution issue. Yeah. Yeah. So I'm using the old-fashioned way with my finger. So if there's a remote code execution issue in that function app, then your adversary has a foothold here. Which one is it?
It's the top button.
This one?
Yeah.
High tech. Okay, I can't use this. So, so let's say you've got a foothold in this function app, and this function app has to serve a business purpose. So it needs credentials and it has to have access. So you may have made an architectural decision where you trust what happens inside this function app. And then what does that mean if an adversary is able to abuse that trust? So they get in here and they go, okay, how is this software talking to the resources that it needs to talk to do its thing? So, okay, it's using managed identities. So how do we get that? I just talk to the the IMDS instance metadata service and get the managed identity credentials. Then that allows me to talk to the key vault. Then we go, okay, what do I have in the key vault? Oh, there's a load of certificates here. What do they do? We grab the certificates and we go, okay, now we have access to the intra tenant, and we say, okay, turns out that this application that the certificate authenticates to has directory read write all permissions. And then we go, okay, now we're going to add a global administrator into the tenant, delete the real global administrator, and then we're going to deploy ransomware across the organization using group policy, for example. So you could have a spreadsheet with 20,000 rows in it saying you've all these problems. But if that remote code execution issue was in there and it was like row 18,000, you may never get to fix it. Then somebody gets into your environment and it's too late. But then the other part of that's valuable in the attack graph is that, you know, it shows the path from like, say, code execution to getting the credentials, to getting, to moving laterally to get more credentials, to use those credentials to authenticate as a service principal. Like, that's the path. So when you think about that as a defender, like, it kind of, like, you know, the asymmetry of this problem, like where the adversaries only have to find one thing wrong. This is a way to kind of flip that on its head, where if we know the breach paths, we only have to break one link in each of those paths. So we're kind of turning that asymmetry back to our favor. And breaking those paths is a very powerful thing to do, because it buys you time to fix all the other issues. And you can say to your leadership, and you can communicate, it's a very, very powerful tool for like defense, communication, and then knowing where to focus. So, yeah, so as Lee mentioned, like the graphs visualize all the possible attacks but this isn't like recording about everything that you try to actually can do. It's about like figuring out what could happen if you don't take action and don't break these paths. So, next one. So yeah, like this is about a mindset change. Like if we were fixing every CVE, then we wouldn't need us. Like we could just automate the whole thing. Like if you're in a boat with like 50 holes and someone hands you a checklist of which holes to fix, like, you know, that's a recipe for disaster. You go for the one that's letting in the most water first. And once we started mapping things out in this way, this is when things changed for us. So we started kind of a shift in our mindset. Like not only did we look at the attack graphs, we started looking at dependency graphs and dependency analysis and looking at how everything fit in together in context. Like threat modeling is a great activity, but if you look at something in isolation, then you miss the risks at the edges, at the boundaries. And you might have like tons of reports from like Qualys or whatever, and not to single them out, but just like a security product. And they won't show you the boundary traversals typically. So that's where the breach paths became very useful. And it allowed us to kind of approach a model for our most important services as well, where we layered them in terms of risk. So we have like a kind of foundational platform-based application, like these types of layers for our services, and we know which are the most important. So if a breach path gets into those foundational layers, then we know that that's where to focus. And also, if we see breach paths crossing between those layers, that's a really important signal that we need to fix that and address it, because that's a boundary violation. And that's where like things get really nasty in terms of security incidents. So, yeah, and then the other thing, by taking this approach, we found these bonus bugs. We found issues in other services and nothing to do with identity, like different parts of the organization. And like the bet that we took with this variant analysis program was to try and tackle issues horizontally at scale. And then like we found that we were tackling issues in business units we didn't even know about. And it just shows the power of like shifting this mindset, like where everyone is kind of blinkered looking at their set of problems. And then like this kind of, that additional context allows everyone to kind of just take that broader mindset, that like holistic thinking and just thinking about things in context, and context really matters. Yeah. So, and then one part of our mission is to prevent repeat breaches. So, and like that's central to the variant analysis program. Like we started the variant analysis effort first. Then we grounded ourselves in this preventing repeat breaches mission. And they really, the breach paths like were super useful in that, because we could abstract them and then turn them into a way to query the environment, to find other instances of those attack paths, other variants. And then like, you know, we're really, directing our efforts with the highest return in terms of the efforts that we're making. So I guess like I found this nice quote somewhere, and it said like, I probably should attribute it, but sorry, security isn't about swatting every bug, it's chess. It's not whack-a-mole. Attack graphs help you see the board. So, so what do we learn? We start by defining the problem. Don't boil the ocean. Like, you know, if you're thinking about embarking on this effort, like, you know, it may seem daunting to like, how do we do this? But you know, this can be done in an iterative fashion, like focus on one area first and then just kind of step by step roll it out. And every time you break a path, that's a win, celebrate it. And this will help kind of embed the program in your organization, build that culture. And there are tools out there to help you with this. So like if you've heard of Neo4j, and like it's basically a technology that allows you to build links between arbitrary things and then query them based on the structure of the data. So this is where the power of this comes from. And it's like building that mapping, or the technical term ontology, between the various aspects of the service. So like you have at a high level a subject, a verb, and an object. So you have like certificate authenticates to service principal. And like that's a very simple relationship that you record in your database. But then when you've got thousands of those relationships, you can query the graph of all of those relationships together. And then that's when it really just opens up. It's like opening Pandora's box. And that link there is from Microsoft, and I think from our red team, if I'm not mistaken. And it's very Azure Entra specific, but it's a really good starting point if this is something that interests you folks. So, and that's it. So attack graphs are there because defenders deserve a strategy, not a spreadsheet. So, thank you. So, any questions? Great, right.
So I'm really down with this idea of the kind of open source kind of graph schemas. You're definitely preaching to the choir in terms of these like security graphs. How do you think as an industry, like, do you think it's feasible that we could move to like everyone kind of publishing like, like this is how my system works at a meta level in terms of like security postures, and that we can get to a place where like this isn't something where like blue team and red team are kind of dissecting docs for ages, and like how do you see the future of this, I guess?
So let me see if I can paraphrase that. Big kudos to open source. How do we see this evolving, and can we get to a point where we have publications in industry? Would that be the right way to word that?
Yeah, I guess like the whole industry is kind of like this. If you build a system, it's kind of...
Yeah, like if you use Entra, here's your thing to make your graph work.
The security posture, right?
Yeah.
Like if you build a system on top of it, you then publish that too.
So like, I think this is a brilliant idea. I would love to see this be a real thing, but like, I think what's practical is publishing the ontology, the mapping, and saying like, these are the types of technologies that we use, and here's the mappings that we created. And, like the example of like, key vault, credential, key vault, certificate, service principal, that kind of graph. Like those mappings would be really useful, and I think portable, and be really useful for people to share. I think sharing the actual graph that represents what's going on in your environment would be a huge problem, because that's kind of, we didn't actually mention that, like, but be careful with your attack graph data. Like, this would be extremely useful to adversaries. So yeah, from an OPSEC standpoint, don't share the graph, but share the mappings will be, because like, I think if there was a community building those mappings and sharing them, then I think, because there's so much common technology in use, like all used in different ways, but I think the relationships would be relatively consistent. So it's a really good question. I'm gonna annoy the people at, yep.
Anyone else? It's okay if you guys don't have questions. We just figured we'd offer.
This is your last chance, like, as soon as we walk off the stage, that's it, like.
All right, cool. Well, that's all we got. If you guys want to chat later, just let us know.
Yeah, thanks so much.